Hello, algebra students. We're looking at radical operations today. So this is the operations of addition, subtraction, multiplication, and division. And today we're just looking at adding and subtracting. So when adding and subtracting terms with radicals, your radicand is your like term. They must be the same. Then you treat them as variables and only add and subtract the coefficients. So let's look at some examples. So we see these have the same radicand in example A. So we simply add or subtract the coefficients. Okay, so in this case, the radicand is 5 in both cases. So we have the square root of 5 and 3 times the square root of 5 minus 2 times the square root of 5. Well, subtract the coefficient. That's 3 minus 2. And that's 1 times the square root of 5. Or you can just write that as just the square root of 5, right? Okay, so that's a case where we have the same radicand. Now the next one we also have the same radicand. 3 for both of them. So 7 times the square root of 3 plus 12 times the square root of 3 is, just add the 7 plus 12, 19 times the square root of 3. Okay, now this next one, they are different. You have 6 times the square root of 8 minus 2 times the square root of 2. However, we may be able to simplify these, and you may say, yeah, we can simplify that square root of 8. So, of course, if we do the cake on 8, so we use 2, we get 4, use 2 again, we get 2, and then 2, and we get our candle on top, the 1. So we have a pair of 2's there, right? So we're going to pull a 2 out, and so that's 6 times the 2 that we pull out, and what remains inside is just the leftover, which is 2. So it's that minus 2 times the square root of 2. So 6 times 2 here is 12, of course, right? So that's 12 times the square root of 2 minus 2 times the square root of 2. And now we do have the same radicand, right? Square root of 2, both of them. So we can combine that. We can do the subtraction. 12 minus 2 is 10. Okay, and that is it. Okay. So the next one, we will look at that same process. For D, we have the square root of 20 and the square root of 5. They're not the same, but the square root of 20 can be simplified. So we'll do that. Let's see where I can squeeze that in. I'm going to go ahead and do it here. Right, kind of small. Okay, we use 2, and that gives us 10. Use 2 there, and we get our 5. Okay, so we have a pair of 2's, right? So we pull out of 2. So that's 3 times, the 3 of course just comes from that. And we pulled out a 2, and what's left inside the radical is the 5. I know that's a little sloppy there. So we have a 5 inside. Okay, so that's still minus 16 times the square root of 5. And now we'll go ahead and take 3 times 2 is 6 times the square root of 5, minus 16 times the square root of 5, and that is negative 10 times the square root of 5. Okay, so one more example with adding and subtracting. And this one has 3 terms altogether. Now we can go ahead and simplify the 3 times the square root of 12 times 2 minus 2 times the square root of 12. See, they have the same radicand, the square root of 12. So we can do that first. And that gives us 1 times the square root of 12. And we still have plus 2 times the square root of 20. Okay, so different radicands, right? You have 12 and you have 20, but we can simplify both of those. So you don't know if you really have the same radicand until you've simplified. So simplify them both. So we'll look at the 12. And let's see, let's go ahead and just do these both over here, okay? We'll do 12, use 2, that gives us 6, 2 again, that gives us 3, and that's it. So we do have this pair of 2's to pull out, and so we have 2 times the square root of 12. I'm sorry, inside is 3. 2 times the square root of 3. And then for 20, we'll do it right here. We've already actually done 20. We don't need to do it again because we have it over here, right? And we had a 2 to pull out, and we have a 5 left inside. So we have this 2 that's already here. Going to pull out another 2. And we have a 5 left inside. Now this 2 here's the one we pulled out, right? Because we had the pair of 2's, the group of 2's. And so we have 2 times the square root of 3 plus 4 times the square root of 5. And those are both simplified all the way down, right? So they're just not the same. We do not have the same radicand here, so we cannot add them. So that is the final answer for that one. Okay, if they're not the same, you can't add them. You just leave it like that. Okay. So I'm going to save that. And now we'll look at the multiplication. And we have the rules here for doing multiplication. Okay, the index must be the same to multiply together. The index, not the radicand. As long as the index is the same, we can multiply. And here's what we do. First step, multiply the coefficients, and then multiply the radicands, and then simplify by the cake method if needed. Okay, so let's look. Simplify these. We're going to multiply the coefficients and then the radicand and then simplify by the cake method. So coefficients here, it's just 4 times 1, right? There's no coefficient in the second one. So 4 times 1, or the coefficient is 1, we might say, if you wanted to write it. So 4 times 1 is 4. Now you multiply 6 times 5, and that's 30, inside the radicand. See, we take that and we multiply by that, and that's what goes inside. So now, simplify by cake method if needed. That's step 3. So can we simplify that? We have 30. Maybe don't remember doing 30. So let's see. Okay, so we would go with 3, and that gives us 10. And then we have 2. That gives us 5, and that use 5. And that's it. There are no groups of 2. Our index here is 2, right? When you don't have it written down, they're both 2. So that's groups of 2 is what we're looking for. There are not any. So you don't pull anything out of the radical. Everything stays in. 3 times 2 times 5, that's 30, right? So it is already simplified, and that's it. So if you know for sure it's already simplified, you're done. But if you are not sure, you need to check. Okay, so next one we have example B. Multiply the coefficients. So 2 times 2 is 4. Multiply the radicands. 6 times 8 is 48. So that goes inside. Okay, so we have to simplify the 48 using the cake, or simplify the radical. So let's look at that. Okay, we use 2. We get 24. 2. See, I'm going to try to write this a little bit neater. Okay, gives us 12. 2 gives us 6. 2 gives us 3. And 3, and that's it. So what can we pull out of that? We still have this 4 here, and we have in there a couple of pairs of 2. So that's 2 times 2 we can pull out, right? Or that's another 4. And that's still there. Oh, sorry. What's inside the radical? I keep doing that. What's inside is just the 3. Okay, that's all that's left inside. So we have 16 times the square root of 3. And that's it. Okay. So I'm going to scroll this up. We won't be able to see the rules anymore, but just remember, multiply the coefficients, multiply the radicands, and then simplify. Okay, so this next one, though, we'd have to distribute, right? So we're going to multiply, but we're going to distribute. So when we take this first one, it's the square root of 2 times negative 2 times the square root of 5. So looking at that multiplication, and I'll just I'll erase this one. So we're looking at that multiplication right there that I have the arrow for right now. So multiplying the coefficients, well, negative 2 is the only coefficient. Multiplying the radicands, you have 2 times 5, so that's 10. It goes inside. So now we do the other one. So now we have multiply coefficients, well, they're both 1. Multiply the radicands. 2 times 2 is 4. So you have that. Well, we will look to simplify each of these, right? Each product we need to simplify. So we multiply this, we need to simplify that. We probably remember, well, you can't simplify 10. It's just 2 times 5. There's no pairs when you get this prime factorization. But 4, square root of 4, of course, we can simplify that. Okay? So what we have is negative 2 times the square root of 10 cannot be simplified, but square root of 4 is 2. And that's it. They're both simplified as much as they can be, and then you cannot do this addition because the first term has the square root of 10, the second term does not have the square root of 10, so they are not like terms in the sense of having the same radicand for both of them. Okay, so that's it for that one. Now the last example is distributing again, distributing twice because we have a pair of, each number has both the rational part and the part with the radicand. So we have to, what we would call FOIL this, or you could call it distributing twice. You're probably familiar with this acronym. So we multiply, we'll do this one first. That gives us 4 times 5, well, that's 20. Okay, so then we take the 4 times the square root of 3. Okay, that's just 4 times the square root of 3, right? Multiply the coefficients. Well, one of them is 4, the other one's just 1. There's sort of a 1 there. There is a 1 there if you want to write it. So 4 times 1 is 4. And then there is no radicand along with the 4. So that's just, again, you might say 1. So all you have left is the square root of 3. Inside the radical is just 3. So then we take this times this, the second one, the 2 times the square root of 3 times 5, or sorry, it's negative 2 times the square root of 3 times 5. So negative 2 times 5 is negative 10, and that's times the square root of 3. And then you have this. So this is negative 2 times the square root of 3 times the square root of 3. So we have the negative 2, because it's just negative 2 times 1. Now, the radical, we do have the square root of, this is where you take 3 times 3, right? What goes in here is 9. I'll write that one over to the side just to make it clear what we did. You have negative 2 times the square root of 3, and we multiplied that by the square root of 3. So multiply coefficients. Negative 2 times 1 is just negative 2. And multiply radicands. 3 times 3 is 9. So that's what we have. That's how we got that. So we simplify each of those. Well, 20 is already simplified. 4 times the square root of 3 is already simplified. Nothing you can do with that. Minus 10 times the square root of 3. That's already simplified. Now, negative 2 times the square root of 9. The square root of 9 is 3, right? So negative 2 times 3 is negative 6. Now we can combine like terms. We have this 20 and the negative 6. Those are like terms. They're just numbers. So 20 minus 6 is 14. And we combine the 4 times the square root of 3 minus 10 times the square root of 3. They both have the same radicand in the radical. So we can combine those. So 4 minus 10 is 6. Just, subtract the coefficients. 4 minus 10 is negative 6, sorry. Negative 6 times the square root of 3. And that's it. Okay, so the homework has some problems that pretty much like these. I think these examples take care of all the kinds of problems in the homework. So that's it for now. Until later, that's all for now.